CBSE Class 12 Practical Skills in Physics. Experiment number 3. Galvanometer, Ammeter and the Voltmeter. 3.1. To determine resistance of a galvanometer by half deflection method and to find its figure of merit. Aim: to determine resistance of a galvanometer by half deflection method and to find its figure of merit. Materials required: moving coil galvanometer, high resistance box, low resistance box, voltmeter, rheostat, Leclanche cell, 2 one-way keys, battery, sandpaper and connecting wires. Procedure: a galvanometer is a sensitive device which is used to detect feeble electric current. The resistance offered by coil of galvanometer to the flow of current passing through it. It is called resistance of galvanometer. Setting up the circuit. Draw a circuit diagram for measuring resistance of galvanometer as shown in the circuit. Clean the ends of the wire with sandpaper before making connections. Make the connections tight and neat as per the circuit. Open both the keys K1 and K2 by removing the plug from them. Determination of resistance R. Introduce a high resistance, that is 3000 ohm, from a resistance box R and close the key K1 only. Adjust the resistance from R till you get the full scale deflection on galvanometer. At this stage, note the deflection angle theta and corresponding resistance R. Determination of resistance S. While keeping the value of R fixed, introduce a small resistance about 50 ohm from the resistance box S. Insert the plug into key K2 and close it. Adjust the value of S till the deflection on galvanometer is exactly half of what it was in the previous step, that is for R. Once you achieve half deflection, note down the value of S and take out the plug from K2. Determining resistance of galvanometer G. Calculate the value of galvanometer resistance G by using the following formula. G is equal to Rs by R minus S. Determining the figure of merit. Using a high resistance voltmeter, measure the value of EMF E of cell. For each set of observations, calculate the figure of merit by using the following formula. K is equal to 1 by theta into E by R plus G. Note down the observations in a table. Observations and calculations. Result: resistance of given galvanometer by half deflection method G is. Figure of merit of given galvanometer K is. To convert the given galvanometer of known resistance and figure of merit into a voltmeter of desired range and to verify the same. Aim: to convert the given galvanometer of known resistance and figure of merit into a voltmeter of desired range and to verify the same. Materials required: given galvanometer, voltmeter of required range, 2 one-way keys, battery, rheostat, resistance box, connecting wires and a sandpaper. Procedure: a galvanometer has low resistance and hence large current flows through it. Due to this, current and the potential difference across a conductor decreases. Hence, the galvanometer cannot be used to measure the potential difference across a conductor. But we can convert a galvanometer into a voltmeter. Determination of current for full-scale deflection. Note the given values of resistance of galvanometer G and figure of merit K. Note the total number of divisions N0 on either side of the zero of the galvanometer scale. Calculate the value of Ig, that is, the current required to produce full-scale deflection in a galvanometer using the formula Ig is equal to NOK. Determination of value of large resistance. Calculate the value of large resistance R required to be connected in series with the galvanometer for converting it into a voltmeter using the relation R is equal to V by Ig minus G. Conversions of galvanometer into voltmeter. Connect a high resistance box in series with galvanometer and take out the plugs so as to introduce a resistance R from it. Tighten the rest of plugs. Galvanometer is now converted into voltmeter. Checking accuracy of converted voltmeter. Connect a standard voltmeter and the converted voltmeter in parallel with a rheostat as shown in the figure. Note the readings shown by both the voltmeter for different positions of the rheostat slider. Rheostat is connected to the battery in such a way that it acts as a potential divider. Record your observations. Observations and calculations. Result: error in actual and measured potential difference values is very small, so the conversion is verified. 3.3. To convert the given galvanometer of known resistance and figure of merit into an ammeter of desired range and to verify the same. Aim: to convert the given galvanometer of known resistance and figure of merit into an ammeter of desired range and to verify the same. Materials required: given galvanometer of known resistance and figure of merit. Battery, rheostat, constant wire, connecting wires, one-way key, sandpaper, an ammeter, a rheostat, resistance box, screw gauge, and a wire cutter. Procedure: a galvanometer is a sensitive instrument which detects feeble current in a circuit, but it cannot measure the value of current flowing through the circuit. Flow of large currents through galvanometer may damage it. Therefore, a shunt resistance is connected in parallel to the galvanometer to convert it into an ammeter. To find the current for full-scale deflection, note the given values of galvanometer resistance G and figure of merit K. Note down the total number of divisions N0 on either side of 0 of the galvanometer scale. Find current through galvanometer for full-scale deflection Ig by using the formula Ig is equal to N0K. To find value of shunt resistance required for conversion of galvanometer into ammeter, by substituting the value of G, Ig and I, calculate the values of shunt resistance from the following relation. S is equal to IgG by I minus Ig. I is the range of the required ammeter. Conversion of galvanometer to ammeter. Find the least count and zero error of the screw gauge and measure the diameter of selected wire and calculate the corrected average diameter D. Calculate corrected average radius of wire R using the formula R is equal to D by 2. Find the specific resistance ρ of material of P from a standard table. Calculate the length of the wire L required for making shunt resistance S using a relation L is equal to pi r square into S by rho. Cut the length of the wire 2 to 4 cm more than the calculated value of L. Connect this wire in parallel to the galvanometer such that the length L cm remains outside the terminal of the galvanometer. Galvanometer with the shunt resistance wire connected in parallel to it is the converted ammeter of required range. Verification. Set up the circuit as per the circuit diagram as shown in figure. Determine the least count of converted ammeter and standard ammeter. Insert the plug-in key and note down the deflections in galvanometer. Find the value of current measured by it. Also know the current I dash from a standard ammeter. Find the difference between two, if any. Take more number of observations by changing the current using rheostat. Observations and calculations. Result. Reading of converted ammeter and standard ammeter are nearly same. Hence, conversion of galvanometer into ammeter is perfect.